Good morning, students. Welcome to our first online class in which I am starting our first chapter named as Integers. Before talking or introducing you about integer, we have to remind you about the two types of number which is very important to tell you before coming to integers, which are which are natural numbers and whole numbers. What is whole numbers? So for this I am showing you a video based on the concept of what is natural numbers and what is whole numbers. Let's have a look.
Maths is all about numbers. Everything that you learn in mathematics is nothing but different forms of number patterns. And actually not just math, but all physical phenomena, natural phenomena, everything can really be explained using number patterns, right? So these number patterns are at the very core of all math or all nature, right? Let's look at a very simple number pattern, right? Let's say 1, 3, 5, 7. What are these? If you look at them, what are they? These are nothing but odd numbers. These are nothing but odd numbers, right? Now you could visualize them as triangles. One triangle, this is 3 triangles. If I divide it further, this will be 5 triangles here, 7 triangles, right? So if I want to divide a triangle into each part, into equal areas, the number of triangles I'll get in each row is going to be an odd number, right? This is one way to visualize it. Now let's add them and see. 1 and 3 you add, you'll get 4. 1 plus 3 plus 5, you'll get 9. 1 plus 3 plus 5 plus 7, you'll get 16, right? What are these? Nothing but square numbers, right? Why do you get square numbers? Because adding triangles gives you squares, right? Two triangles make up a square, which is why adding these numbers that represented triangles gave you a square. So it's just one way to see it, right? There's another way we can visualize triangles. Let's take 1, then I have 1 and 2, 1, 2 and 3, 1, 2, 3 and 4. These are all triangles, right? The first one has just 1 point, the second one has 3 points, the third one has 6 points, the fourth one has 10 points, right? So we call all of these as triangular numbers, right? We call them as triangular numbers because as you see, they form triangles, right? Now again we said if you add up triangles you get squares. So if you add these triangles you should again be getting squares, right? Let's try it. We have 1 first. 1 and 3 gives you 4. 3 and 6 gives you 9. Square again. 6 and 10 gives you 16. Square again, right? So you get these square numbers. These are nothing but square numbers, right? 1, 4, 9, 16 are nothing but square numbers, right? You can see that in the figure also. What we did here, 1 plus 3. So 1 and 3 gave you 4, right? I'm just rotating the triangle and putting it on top. 3 and 6 gives you 9, right? 6 and 10 gives you 16, right? So multiple ways in which you can visualize a simple concept of triangles and squares, right? It actually links numbers, geometry, algebra, everything, right? Which is why number patterns are so fascinating, right? When you start visualizing number patterns, they become extremely fascinating. So there are some number patterns that you already know, right? The very basic one, the first thing that you learn in math, what is it? Counting 1, 2, 3, 4, 5, 6 and so on, right? This is actually a number pattern and it also has a name. It's called natural numbers. We normally represent it by n, right? So on a line 1, 2, 3, 4, 5, these are nothing but natural numbers. We can now count everything. Let me take a basket. There's 1 apple here, 3 oranges, 4 fruits in total, right? Now what if we want to represent what is left in the basket, right? We could represent the fruits using natural numbers. How do we represent what is left in the basket? There is nothing, right? There's nothing. How do we show nothing with natural numbers? You can't, right? Which is why we now bring in a 0, right? If we include 0 to the set of natural numbers that we already had, we now get whole numbers. These 0 to infinity are nothing but whole numbers represented by W, right? Again, there are infinite such numbers. Let's now see what numbers we get by adding two whole numbers, right? Say we add 2 and 5. We get 7, which is also a whole number. Try 3 plus 8. That gives you 11, which is again a whole number, right? So adding whole numbers is still giving us whole numbers, right? So we can still work with these. Now what happens if we subtract these two numbers instead, right? We do 3 minus 8. What does that give you? Minus 5. Now minus 5 is not a part of our set of whole numbers, right? Is not a part of our set. So what do? To be able to represent minus 5, we add another set of numbers to the left of 0. These are nothing but negatives of the natural numbers, right? So we add negatives of the natural numbers to the other side. This entire set of numbers that we now have is called as integers, right? Represented by I, again an infinite set.
Hope you like the video. Now I am coming to our main topic, which is what is in integer. And now for this I am going to show you another video which is based on the topic of what are integers. So please have a look.
You will find it interesting to know how much the temperature of a place can vary across the world on any given day. For example, it could be 29 degrees Celsius above zero in Miami. And at the same time, it could be 3 degrees Celsius below zero in Canada. It is good to know that we have different types of numbers available to represent these varying temperatures across the world. Considering our scenario, the temperature of 29 degrees Celsius above zero is a positive number, and we write it as 29 degrees Celsius. Whereas the temperature of 3 degrees Celsius below zero is a negative number, and we write it as negative 3 degrees Celsius. But do you know how low do these negative numbers go? Well, you might already know that they go as low as the positive numbers go high. It means that both the positive numbers and the negative numbers are infinite. Whether the numbers are positive and above zero, or negative and below zero, all whole numbers and their opposites are called integers. This means that the numbers on the thermometer, the ones we count with the floors of a building, are all integers. Hope you got an idea of integers. But what about zero? Is zero an integer? Well, zero is an integer too. It may be near the bottom of the thermometer, but it's at the center of the number line. If you move right off the zero on number line, you get 1, 2, 3, 4, 5 and so on. That is positive numbers. And if you move left of the zero, you get negative 1, negative 2, negative 3, negative 4, negative 5 and so on. That is negative numbers. So positive numbers, 0 and negative numbers together make the set of integers. Can you choose integers from this lot of numbers? Clearly, negative 1, 5, 29, negative 17 are all integers, and the rest of the numbers are not integers. Here is an important point to keep in mind. There are no fractions or decimals in the collection of integers. Now, here is a quick question for you. Alicia stands at 3 on number line and moves 5 units left to reach her school. Can you tell the position of Alicia's school on the number line? If you move 5 units left from 3 on the number line, then you reach at negative 2. So, Alicia's school is at negative 2. Having learnt about integers, it is time to know how to compare two or more integers. You probably know how to compare positive numbers very well. Like if you are asked which is greater, 4 or 5, clearly 5 is greater than 4. But if you are asked which is greater, negative 4 or negative 5, This is where negative numbers can be little tricky. Since 5 is greater than 4, so you must be tempted to think that negative 5 is greater than negative 4. But it is not true. Actually, negative 5 is smaller than negative 4. To understand this, let's look at the number line again. If you start at 0 on the number line and keep moving right, then the numbers get greater and greater. 1 is greater than 0, 2 is greater than 1, 3 is greater than 2, 4 is greater than 3, 5 is greater than 4, and so on. But what happens if we go in the opposite direction, that is, to the left? As we move to the left, the numbers get smaller and smaller. 4 is smaller than 5. 3 is smaller than 4. 2 is smaller than 3. 1 is smaller than 2. And 0 is smaller than 1. Can we apply the same rule on the negative side of the number line? Yes. The numbers get greater when you move to the right, and the numbers get smaller when you move to the left. Since negative 5 is on the left side of negative 4, so it is smaller than negative 4. And you can use this idea no matter what the numbers are. For example, 400 is greater than 300, since it is to the right of 300, and negative 400 is smaller than negative 300, since it is to the left of negative 300. So, the positive integers are on the right side of the 0 on number line, which means they are greater than 0, and the negative integers are on the left side of the 0 on number line, which means they are smaller than 0. So, when you compare two positive integers, farther the number on the right of the number line, greater the number is. For example, 10 is greater than 5 and 90 is greater than 80. When you compare a positive integer with a negative integer, remember that a positive integer is always greater than a negative integer. For example, 15 is greater than negative 5 and 40 is greater than negative 40. Now, when you compare two negative integers, farther the number on the left of the number line, smaller the number is. For example, negative 15 is smaller than negative 5 and negative 30 is smaller than negative 20. Let's try out a problem now. Arrange the numbers negative 3, 5, negative 10, 0 and 7 in ascending order. Ascending order means from the smallest to the greatest. The smallest number here is negative 10, so it comes first. The number greater than negative 10 in the given numbers is negative 3, so it is the second number in order. Then comes 0, 5 and 7. You can verify your answer by marking these numbers on a number line. They must lie in the same order from left to right on the number line as found above. In a nutshell, integers can be positive, negative or even 0. As you move to the right on the number line, the integers get greater, and as you move to the left, they get smaller. Comparing integers become easier with more practice. So, keep practicing.
Hope you understand the concept of integer. Now, adding more to it, the following video is based on the usage of integer. The usage of integers in our daily life. So, have a look to this video. It's very interesting.
Introduction to integers.
One, two, 3, 4, 5.
Kathy, come downstairs.
Okay, Father. 1, 2, 3, 4.
How will you determine that the steps you are taking are below ground or above ground?
I don't know, Father. Can you please explain it to me?
Suppose the stairs going from the ground floor to the first floor are counted with the positive sign. For example, +1, +2, etc. And the stairs going from the ground floor to the basement are counted with the negative sign. For example, -1, -2, -3, and so on. The ground floor is considered as 0. This is the tradition to show depth with the negative sign to differentiate it from height.
0, -1, -2, -3, -4, -5. Here, -1 indicates first basement, -2 indicates second basement, and -3 indicates third basement.
Yes, baby. Kathy, look here. Integers are widely used in daily life, as shown here.
Father, look at this. The depth of the submarine from the sea level is measured with a negative integer.
Very good. We see that integers are widely used in our daily life. For example, integers are used in measuring the temperature, height, depth, and showing transactions in bank statements.